Mm, Good day. This is Kenya again. I thank you very much for um, watching these tutorials we are having. We are discussing mathematics made simple for all, and we are going straight to Algebra 2. After a thorough discussion of Algebra 1, we have now moved on to Algebra 2. Now, in Algebra 2, if you try to review our discussion in Algebra 1, in Algebra 1, we are looking at what is the meaning of algebra. We looked at collecting like terms, removing brackets by applying the distributive property, interpreting word statements to algebraic expressions, solving linear equations. In Algebra 2, we are going mainly to look at how we can interpret word statements into quadratic expressions. We see what quadratic expressions are. Expansions using one-term and two-term multipliers. What we mean by a coefficient. Identities, perfect squares, factorization, and then solving using the concept of factorization. Now, if we jump in straight to what we mean by quadratic expression, these are expressions whereby the unknown is raised to a power of 2 or more. Remember, in Algebra 1, the expression was raised, the unknown was raised to a power of 1, but now it's more than 1. Like if you talk about x squared plus 3x is plus 5. X squared plus 3x plus 5. That one is quadratic. If you look at some word statements leading to quadratic expressions, like if somebody gives you a field, a rectangular field, where the length is twice its width, and you to write an expression for it. Or if somebody draws a figure like that and the field is having two rectangles, one rectangle, the side is 2y, and the other on the side is 3, and they have a common width of 5y. How can you write algebraic expressions for those? So if they say, try the area of a rectangle whose length is twice the width. We know area is always length times width. So if the width is y, the length will be 2y. So if you say 2y times y, you get 2y squared, which is an expression that is showing the area of that rectangle. It is, you can see it is quadratic. The length, if you look at the figure that we are looking at the other time, this length now will be 2y plus 3, and the width is 5y. So 2y plus 3 and the width is 5y. Therefore, the area will be 2y plus 3 in bracket multiplied by 5y. Expanding that, you open brackets, which means 5y multiplied by 2y, you get 10y squared, and 5y times 3 is 15y. So that's expression. Or you could split and look at the area of the one part. If you look at the area of this part, this will be 2y times 5y, which is 10y squared. And the area of the other part, 5y times 3, which is 15y. So if you add, you get the same answer as somebody who has said, 10y squared plus 15y. So they are equivalent expressions. So you can use that idea to do a quiz. If somebody says, expand the following, 2y in bracket 27y plus 12. That means you're going to open brackets and multiply this in the brackets. 4a into 3a minus b, do the same thing, open brackets. m minus 5n, multiply it by 3m. You can do that. You can pause this video and try that. So the area of a rectangle is 10 centimeters. The length is 2 centimeters more than the width of the breadth. Write the expression. Now you have the length is 2 more, which means if the breadth is x, the length will be 2 plus x. And you multiply those two, you get to 10. Open brackets. If they want to get area of this triangle, do the same thing. Say a half BH, which will be a half 2x into x plus 5. So they want you to practice that by opening brackets. So which is something that I want you to try. Look at two-term multipliers. If there has been one-term multiplier as we saw, this was one-term multiplier. You have one term, this is 5y is multiplying into the brackets. But now if there are two-term multipliers, then you have to open the brackets. This x multiplies into this bracket, and 1 also multiplies into this bracket. So this is how we do it here. And then you expand. So which means you first look as if it's one term multiplier as we did, x multiplying to this bracket and 1 multiplying to this bracket as we are doing it here. So one time multiplier, and then you can expand and get this answer. You can try 5y times 5 minus y times 5 minus y. Do the same thing, open brackets, and you do it as if it's a one term multiplier, and then you can get your answers like that. So you can also use statements. A father is 6 times older than the son. In 3 years time, the father will be 4 times older than the son. Write a different expression for the father's age. So you can do that by still using that concept. If the father is y, if the son is y, then the father will be 6y. And then in 3 years' time, that means you're adding on 3 years for each. And then this one will be 4 times older. So you can try that expression and still get the answer, as we are going to see. A man is now 4 times as old as his son. 8 years ago, the product of their ages was 160. Then you can write an expression for that. This is a good application for the two-term multipliers. The product of the ages of 2 sisters is 40. One of the sisters is 6 years older. Write down an algebraic expression for that. So this is a good application for that kind of work. And then you can expand this using the two-term multiplier, as we can illustrate in the solutions here. And you're going to open brackets as we've been saying, then also bring in the concept of a coefficient. What we mean by a coefficient. A coefficient, these are any numbers in front of the letter or constants in front of the letter. Somebody says the coefficient of 3x squared minus 8x plus 9. That means the coefficient is going to be 3. And the coefficient of x squared is 3. The coefficient of x is minus 8. You see, this is the number in front of x squared. This is the number in front of x. Okay, so let us try to look at the solutions of our work. Somebody said x plus 7 into x minus 9. So you have open brackets, x multiplied to x minus 9 and 7 multiplied to x minus 9. And then you can get your answers like that. So that's how we can use that idea. You can also solve the other ones using the same thing. You have said 2x into x minus plus a half, and then minus 3 into x plus a half. Then you can get the answers. You can complete the remaining exercise, as you say. Then identities and perfect squares. The first identity is a square of the sum of 2 terms. So a plus b is a square plus 2ab plus b square. That means the first term square plus 2 first term times second term and get plus second term square. So that is how we use that identity. And you can use the previous examples to show this. This is how you do it. Then if you look at the second identity, a square of a difference of 2 terms, a minus b square. So a square minus twice the first term and the second term plus the second term square. And you can expand that using that idea as you see here. Then the third identity is the difference of squares. If you look at the first and the second identity, it's either repeat of brackets summing or repeat of bracket difference. So a plus b times a plus b, and you're getting this as the first identity. When the difference of squares, you are seeing that now it's a plus b, a minus b. So the other one has been either plus plus or minus minus, but this one is a plus b, a minus b, which means the signs are changing, and you can get it using that concept. So if you expand using the difference of squares, you can see that it just becomes 1 square, subtract another square. As you see here, y square minus 7 square is y minus 7, y plus 7. You can have a quiz to try and practice those expansions of the first and the second identity. Then factorization. Factorization of quadratic expressions, that involves getting factors of the constant. That is the third term. So if you have a square plus bx plus c, that means the middle term is going to be a sum, and the last term is going to be a product. So that's how you can expand that. If you look at these examples, factorize x squared plus 5x plus 6. Factors of 6 are those. So the sum of 5 will be 2 and 3. So you take factors 2 and 3, and the product will be 6. So if you do that, you can see that 2, 3 replace the 5. And then you can easily factorize using that idea. So it means they become 4 terms, and you can easily create the brackets for that. So the more examples, they said factorize k squared plus 12k plus 36. Get factors of 36, which is going to be 6 and 6, which is the sum 12, and the product is 36. And then you can write 6, 6 to replace the 12, and you can get the result like that. They say factorize this. So now you can use that idea I've talked about. And you need to know the following, that if the middle term is a plus and the last term is a plus, that means both factors are positive. So the middle term is a minus and the last term is a plus, that means both factors are negative. If the middle term is a negative and the last term is a negative, that means the bigger factor is a negative. If the middle term is a plus and the last term is a minus, that means the smaller factor is the one is going to be a negative. So factorize using a difference of squares, you can use these ideas and then evaluate using a difference of squares. So solve the quadratic expressions. If you are solving quadratic expressions, we factorize, then equate to 0. And you can see, so you can factorize normally. When you equate to 0, that means one bracket is equal to 0, another bracket is also equal to 0, and you can get your answers. So you can try more from our work, and then you can use this quiz, solve the following unknowns using our concept of factorization. So thank you very much. We shall meet in another video. We had very little time for this, but I shall meet and discuss more. Thank you very much.